Hello students, so here's assignment 3.4 where our focus is now to sketch the various quadratic functions. So let's go. Right, so here's the first one that I ask you to attempt. So there are two functions over here. A is y equals to x squared minus 7x plus 6. B is y equals to 5x minus x squared. So for both of these examples, I want you to first of all express it in terms of the completed the square form, then state the maximum or minimum point, and then sketch it, right? So how do we do this? Let's take a look. Okay, so let's take a look at for A first, right? So for A, we have y equals to x squared minus 7x plus 6. Perform completing the square, right? You do this, and then we get y equals to x minus 3.5 squared minus 6.25. If you leave your answer in fraction, it is fine also, right? Because if you give the equivalent value of the fraction, is fine. So again, how does this work, right? So I have a 7 or negative 7 as the coefficient of x. So I ignore the x, take the 7, divide by 2. That gives me 3.5. So plus 3.5 squared minus 3.5 squared. Now, after that, the first three terms, I factorize it because this is a minus 7x. Another way to think of this is that this is actually the special identity, right? A squared minus 2ab plus b squared. It is also the same, right? Similar, same form. Okay, so this becomes a minus b bracket squared. And then, of course, minus or negative 3.5 squared plus 6. Now, notice that this one is 3.5 squared first. Then you subtract it, right? So it's a bit different. Sometimes you got to be aware which one goes first. So in this case, this one you are supposed to square first. Okay. So in this particular situation, right? In many situations, when you do substitution or what, you're not supposed to square first. You're supposed to recognize the negative first. So just something to highlight, because I've seen some students who get confused by this point. But anyway, you do it carefully and properly. This is the result that you get. So we did part 1. Okay. So of course from here, let's identify the minimum point. The minimum point, first of all, the minimum y is going to be negative 6.25, which is just our k value. And then our h value is actually 3.5. So here we go, we got our minimum point. So with the minimum point, and then of course from the original function, we know that the y-intercept is 6. We can actually very quickly sketch out the graph, right? So it is a U-shaped graph. Okay, y-intercept at 6, minimum point at this position here 3.5, and negative 6.25. And of course, in this particular example, there are x-intercept. So we can obtain the x-intercept quite easily. I think that one you can just work it out separately. There are many ways to get the x-intercept, so I won't go into detail here, because all they want is for you to show me, right? Show me that you have the graph of this sketch. So for 4b, same procedure, but this time round the a, or rather the coefficient of x squared, is actually negative 1. So I take out negative 1, this is what I have. Repeat the procedure, right? So take 5 divided by 2 is 2.5, so I add 2.5 square minus 2.5 square. After that we factorize, this is what we have, and then after that we distribute or expand the negative 1 back into the square bracket. This is what we have. Okay, so this is the form. Now because the a is negative 1, this is going to be an n-shaped curve, so we are going to have maximum point instead. So maximum point, h value is 2.5, y value is 6.25. So here we go. So well, here's the interesting thing, right? We take a look at this and we can tell already the y-intercept is actually 0, which means the graph actually cuts the origin, right? So at 0, so it cuts the origin, and then after that the other x-intercept is actually 5, right? So the maximum point we have, just label the graph, and then that's your curve. Okay. Right, the next question. Again, this time round we have 2 examples. Okay, you can see that the first one, A, you can tell already this is going to be a U-shaped curve. B is going to be an N-shaped curve, and that's why I give you 2 examples like this, so that you practice one of each type. But this time round, instead of asking you to complete the square, I want you to factorize it, right? Factorize first, sketch, then after that identify the maximum minimum point. You notice that we still get the same information. We still want the same information regardless of which form of the quadratic function we get. Just that the sequence, which information do we get first, which information do we get last, the sequence could be different. but we still get all the same information eventually. Okay, so something for you to think about. Okay, so here we go. The first one, 5a, we factorize it. This is how it looks like in the factorized form. You have a lot of practice with factorizing already, so I don't think that should be an issue for you. Right, so after factorizing, this is what we have. So we know our roots, right? The x-intercept is going to be -4 as well as 1. So just draw the quadratic. The x-intercept is -4 and 1. That means my y-axis is a bit more to the right of the turning point, nearer to 1 than -4, right? So after that, the y-intercept, you can see that it's actually -4 right there. Okay, so after we do this, we sketch this, we are supposed to find the minimum point. So to find the minimum point, we need to find the h and k. Well, if we know the x-intercept, then the way to find h will be the average of the x-intercept, in this case -1.5. After that, we substitute the value of h into our original function. We find the value of k. Our minimum point will be hk. So -1.5, comma, -6.25. Okay. One more example. This time round, we know there's going to be an n-shaped curve. So n-shaped curve, what we do is, again, we take out the -1 as a factor first, because we know that it is there. Then after that, what's inside the square bracket, we just factorize it. This is what we get. So this one, you can see actually the two factors here are exactly the same. Okay, so what this means is that well, there is only one root, right? Both the x-intercept is -1, so there's only one x-intercept for this particular example, and it's right here, as you can see. So the maximum point is the y-intercept for this situation, and of course the y-intercept is -1. You can see from the original function, right? So you sketch this. Okay, so the maximum point at -1. The y-intercept at -1, so that's how it looks like. Finally, they want us to know, same thing, write out what is the maximum point. Actually, from the sketch, you can already tell what is the maximum point. But just for consistency's sake, we go through the entire process of finding h by average of the two roots, and the two roots happen to be the same. So actually, my h is -1. And then my k value, if I substitute it in, my k value is 0, therefore maximum point -1 and 0. Okay, so with this, I hope you are more comfortable with sketching all these quadratic function. Okay, so all the best. Hope you do well in your mathematics. Yeah, have a nice day.